Traditional medical grade prosthetics are expensive, and for children who are still growing, they can often have a very short lifespan. For that reason, many children need prosthetics that are underserved. With us today is Dr. Albert Monero, who's working to change that. His non-profit, Limitless Solutions, uses both Fusion 360 and 3D printing to create personalized prosthetics for children at a fraction of today's average market price. Please welcome Albert Monero.
I was studying at the University of Central Florida in aerospace engineering, and I came across an email from a local family in Orlando that really opened my eyes to an unknown challenge. Can you think back to the first time you saw a sonogram, or a friend or a loved one saw one? There's a lot of emotion that goes into that moment, right? There's joy, there's some nervousness, there's all that excitement and anticipation for what's going to come next. But for about 5,000 families a year, what they see on the sonogram looks a little different. Amniotic band syndrome is one of the leading causes of congenital limb differences. For these children, there's a tendril in the womb that will wrap around a growing limb bud and cause a limb, an arm or a leg, to not fully grow. When you see that on the sonogram for the first time, it may come as a shock. It's not genetic, it's no one's fault. There's nothing you can really do to prevent it. It just happens. But these children go on to be incredible. They can do everything. But there are certain challenges, and those are engineering challenges we would like to help fix. The reality for these families is that access to prosthetics for children are quite complicated. The cost of a prosthetic that has full finger dexterity and looks like a human form could be well over $50,000. And children are always growing, and you can imagine having to change out their complex bionic arm as often as you change out their shoes. It would really get expensive, and the insurance companies feel the same way. What we also find out is that because prosthetics are normally driven for the adult market, they're too heavy, they look like doll plastic, which often makes people feel like they're apologizing to the world for being broken. We saw all these opportunities as a chance to be able to use engineering and creative art to be able to completely change the story for what prosthetics look like. This was all inspired by a rubber duck. We wanted to be able to give kids back the opportunity to grasp such an organic, whimsical form. It's so simple, but it's complex in the fact of the mechanics that go to pick it up. This was one of our very first prosthetics for Alex, and you can see him learning how to use it using an electromyographic actuated system. We did not have that $50,000 in our budget at my kitchen table. We had our coffee money, which is about $300 at the time, pooled between all of us working on the project. So we came together and we developed this prototype for Alex to be able to fully integrate and use in his daily life. And now at his school on Superhero Day, he dresses up as himself. But we were at the very beginning, so this was only open and close manual grasp by flexing his bicep muscle on the limb that has a limb reduction. We really wanted to be better. We wanted to be able to play the piano and to be more expressive and to inspire him to go on, to be able to help others with technology. We really had to change everything about how we do traditional design. And in order to do that, we found that Fusion and Eagle and Maya were really effective for this. We're creating really organic shapes that are really hard to make in traditional CAD softwares. But we still need that parametric design for forms that have to be rigid, structurally sound, and have to be able to integrate together with mechanical parts. On the PCB design, it was really complex. The very first model was a bunch of batteries, a bunch of wires, and a breadboard kind of packed all in, much like everyone's first prototypes. And as we started to streamline that, harkening back to that aerospace moment of how do you get all of your avionics into the system, we realized that there was an opportunity to split the artistic form from the structural core. And we started exploring how to take these concepts from 2D sketches, even on the back of a napkin, and turning them into really complex organic forms in Maya. To bring it to life, we worked with Stratasys 3D printers to be able to print in ABS plastic at very high tolerances to be able to create these type of devices. In Florida, where I'm from, if you leave a part in a car that's made out of PLA plastic, it turns to Play-Doh. So one of the reasons we've been driven to use ABS plastic. With our function, we've been striving to be able to give that individual finger articulation to maximize the function and the expression. Above that structural core in silver, we've been able to add these interchangeable artistic sleeves that look like kids' favorite superheroes, favorite characters, and anything else they could really want. For a child, that moment when they get their first arm changes everything. It's very modular. The hand will actually detach and is on a USB-C for power management. The cuff is tailored directly to them, and it even gives them the opportunity to be able to change how tight it is across the course of the day. It even has Bluetooth in the hand, and when you get to see their face light up when they learn how to use it, like that, it totally changes everything from an engineering side. But in the process, what we learned is that it was so much more than just being able to pick things up. It was about the expression. It was about changing the conversation for these children in everyday activities. When you're at the grocery store and someone sees you from across the way, that moment for the child could be really, really difficult. They get a lot of weird questions. What's wrong with you? How did it happen? How did you lose your arm? Was it an alligator? And we want to change that entire conversation. We want it to be a facet of their personality, to be so expressive that now what they often hear is, that's so cool, how do I get one? And to be able to include that expression, we wanted to be able to include the child in the design process. And so we went to work building a web portal so that they could be active in the design. We partnered with some really great companies like the Halo franchise and League of Legends to bring their game characters to life as part of the arms. We uploaded our OBJ files into this secure portal, and then the families are able to choose from different 3D designs, different color palettes, and then they can actually go in and just select the parts that they want to change those colors. The arms are interchangeable, so to start, we said, why don't you pick 2? We found out that they really end up designing a lot more than 2 different arms. And we think that's the best thing possible. We want them so invested in the different designs that they wear and take to school that it's like second nature to be able to use one hand to swap out the design and move about the day with all that expression that it empowers. This was the result. We created some really, really beautiful arms. We had to change how we even do our paint process. We worked with some people who work for Universal Studios in Orlando, and we were able to learn this automotive airbrush process. These images are of 3D printed parts. They don't have the same contours that you'd expect to see straight from the printer, and there's a huge team that helps make that happen. We wanted to maximize that expression and be able to control the narrative by not just building boy arms and girl arms, but we focused our designs around different empowerment phrases. So we have a warrior class, ethereal, serenity, and shadow. Each one of these empowerment phrases means something different to the child that will select it as their part of their arm. This is that impact moment. For us, we were able to give kids back that opportunity to be able to interact with 2 hands for daily tasks. What we didn't expect is the impact it would have on them socially. That going to the grocery store would now be fun because they were picking up everything with their new bionic arm, and people had to know how they got that arm. It also changed how they viewed themselves, in changing it from a defect mindset to one that's an expressive extension of their personality and expanding their reach in their daily life. And of course, there's a lot of rubber ducks in the lab. In order to do that type of design, we had to branch out much further than our traditional engineering design framework. We now have a team of over 30 undergraduate students on average each semester, and they come from engineering, video game design, fine arts, digital arts, creative media, computer science, and everywhere in between. It looks nothing like a traditional robotics laboratory. It's part makerspace, part collaborative zone. And our hope is that that interaction of different majors and different specialties will drive the design further. And one of the things that we couldn't have done without building that type of mindset was actually creating video games. When you take off the arm, you leave on the electromyographic controller, and you're able to play a video game, and depending on how hard you flex, the character will do different superpowers. And this is important because those different superpowers come back to be able to help us teach children how to do different types of graphs and some personalized expressions. And don't worry, there are parental controls as well. This app is actually in the Android App Store right now, and it's able to be unlocked with a Bluetooth controller so kids can play on their parent's smartphone, and their siblings and friends can also play just by tapping the screen. Depending on how hard you're flexing your muscle, the character will jump at different heights. We even have challenge modes that help them be able to learn certain patterns that are going to help them really control that multi-dexterity part of their arm. In application, it's a lot of fun. This character runs through the limitless factory, and you have to keep the mayhem at bay, otherwise the run ends. We took that app design, and we were able to create a calibration app so that parents could be involved in the process. It allows the family to be able to recalibrate those different gestures, which are based on magnitude or pattern recognition on the arm. And as the children level up in their video games, they actually unlock new functionality on the bionic arm. For us at Limitless Solutions, we're still at the very beginning. Each one of these arms costs about $1,000 in hardware, a long way away from what the current market price is. Our hope is that this is the bionic arm for the entire world, and that access to prosthetics will be as easy as access to eyeglasses or braces. We want to make more of these type of smiles so that kids can go throughout their day, not afraid to go to school or afraid to engage socially, but to be really proud of who they are, to change those mindsets and give them the opportunity to excel, whether it's in the classroom or on the soccer field as well. Our hope is that this authentic use of different softwares from Eagle to Fusion and Maya allows us to bring in different specialties to be able to create a really holistic solution for kids and to really extend their reach on everyday things. Thank you very much.